I am going to show you some more complicated ones. These are very, very simple, and we're going to do some more that have more steps to it. If you had done the ln with this, you'd have the ln of 10 to the x is equal to the ln of 8,000. Bring this down. So it's x times the ln of 10 is equal to the ln of 8,000. And divide both sides by the ln of 10. We good? No? The next one that we're supposed to be doing is we're supposed to be solving this equation. 7e to the 2x minus 5 is equal to 58. On the other two problems that we did, remember that step 1 was done for us. The exponential part of the function was by itself. Here, first of all, I need you to tell me what is the exponential part of this function. It has to take the base with it. So it's not just the 2x, it's the e to the 2x. Not the 7, just the e to the 2x. Because without it, the exponent doesn't make any sense. Okay, so this is my exponential part of this expression. Okay, that's the part that needs to be sitting by itself before I take the log of both sides. Okay, so what's my step number 1 going to be? Add the 5 to both sides. Gives me a 0 pair, so this is 7 times e to the 2x is equal to 63. Now I got to divide by the 7. So e to the 2x is equal to 9. And now you're stuck. Somebody want to tell me whether I'm going to do the ln or the log? The ln, because my base is e, because it'll cancel out. You can't move the exponent. Before you start moving anything, you have to have taken the log or the ln of it. Okay, you can't use that property until you're working with the log. That property only works for logs. So we got to take the log of both sides first, and then I can move that 2x down. But I don't necessarily have to this time, because what do I know about the ln and e? They cancel out, and this just becomes 2x is equal to the ln of 9. And then divide by the 2. So x is equal to whatever the ln of 9 divided by 2 gives you. Did you make sure and close off your parentheses behind the 9? .09? Okay, good deal. Are we good here? Everybody got this? Okay. Next example. Checkpoint 4 says we want to solve this equation. 3 to the 2x minus 1 is equal to 7 to the x minus 1 plus 1. Oh my goodness. I can't move anything because they're both exponential expressions, right? Just take the log of them then. Okay, so let's do the ln of 3 to the 2x minus 1 is equal to the ln of 7 to the x plus 1. I'm just going to take the ln of both sides since I really can't move anything around. I got exponents on both sides. Now what do I do after I take the ln of both sides? I can take those exponents down. So I've got 2x minus 1 times the ln of 3 is equal to x plus 1 times the ln of 7. The thing I want you to kind of keep firmly in mind here is the ln of a number is just a number. Okay? So it's like having a coefficient. So I'm going to take that ln of 3 and I'm going to distribute through my parentheses. Just like it was a number. So I've got 2x times the ln of 3 minus the ln of 3. Everybody see it? Let's do the 2x times the ln of 3 and the 1 times the ln of 3. Then I got to do the same thing on the other side. So I've got x times the ln of 7 plus the ln of 7. No, because, okay, not like terms. Now, just like every other time when I'm trying to solve for x, I got to get everything that's got an x on one side and everything without x's on the other side. So the minus ln of 3 needs to come across, right? So I'm going to do that by adding the ln of 3 to both sides. And I don't have any like terms, so it's just going to get listed over there. So I'm going to have 2x times the ln of 3 is equal to x times the ln of 7 plus the ln of 7 plus the ln of 3. That's exactly right, DJ. That one that's got the x in on this side, I need to subtract it from both sides. Again, those aren't like terms. I can't combine them together, so I just got to list them. That's 2x times the ln of 3 minus x times the ln of 7 is equal to the ln of 7 plus the ln of 3, because that's a zero pair and it's gone now. Now I have it sorted. Yep. Nope. All non-like terms. I just got to list them all. Pretty much. Now, this is the trick, and it comes up a lot in every other math class that you might possibly have to go into past this, except statistics. This doesn't use any algebra. If you have the variable in more than one place, then what you try to do is you try to factor the variable out. So if I pull the x out in front, then what's left out of this term? 2 ln of 3. There's my minus sign. If I factor my x out of here, what's left? The ln of 7. And then, of course, I'm not doing anything to the other side, so I've just got to write it down. Now, I've got x times that thing, so I can just divide by that thing. It's kind of ugly, but I can still divide by it, right? So that'll get it on over there. The only thing that becomes a problem is you do have to be very careful when you put this in your calculator to try to make sure that you have the correct answer. So you're going to need a parenthesis so that for the whole top here. So you've got the ln. It's going to give you a parenthesis. Close that off. Plus the ln, it'll give you that parenthesis. So do your 3 and close that off, and then close off the top. So you got lots of parentheses that you have to use when you type this in. Okay? Then you're going to divide that, and you got to have another parenthesis. Anytime you've got more than one term in the top or the bottom, you got to put parentheses around the whole thing. You're going to put your 2 and your ln. It'll open that parenthesis, close it off after the 3, type in your ln again, close off after 7, and close off the bottom. If you type it in that way, then you're going to get the answer to that expression. Is that what y'all got? 12.11. Let me check it. Checkpoint what? 4? 12.11. Alright. There's one more type of equation where you might have these exponentials. There's another process that you're going to need to do. This is in checkpoint 5. I'm hoping at this point that when you look at this, you see you got how many terms? 3, right? 3 terms on the left-hand side. That's called a trinomial. And I'm hoping at this point that you are noticing that you've got an e to the 1x and an e to the 2x. That's an x. Checkpoint 5 is in your book. You can look. This we're going to do with a u substitution because this is a quadratic type equation. Remember when we did all of these in chapter 3? Same idea here. If we let u be equal e to the x, then u squared is e to the x squared, right? Isn't it? If I square one side, I got to square the other. But if I've got something, a base that's being raised to 2 different powers, what do I do to the powers? Multiply them together. So this is the same thing as e to the 2x. Do you agree with that? Okay, so in your equation over here, everywhere you see e to the x, you're going to replace it with a u. And everywhere you see e to the 2x, you're going to replace it with u squared. So I come back over here, e to the 2x, u squared, minus, there's an 8, and e to the x replaced with u, plus 7 equals 0. So now is it easier to see this is a quadratic type equation? Because now that's just something that I can factor very easily, right? How about u minus 7, u minus 1? Does that not multiply together to give me positive 7 and add together to give me negative 8? Okay. So that means then, what do I do to solve this equation? I take each factor and set it equal to 0. So u minus 7 is equal to 0, and u minus 1 is equal to 0. So u is equal to 7, and u is equal to 1. Now, we're not finished with this problem, right? Because anytime I do this u substitution thing, what do I have to do? Switch it back. So u is the same thing as e to the x, right? So e to the x is 7, and e to the x is 1. Now, what do I do with this? Take the ln of both sides, right? Yes? Right? Because I'm just back to one of these problems that I started with originally, one of those nice easy ones at the beginning, right? And the ln and the e cancel out, and so I just get x is equal to the ln of 7, whatever that is. And now I take the ln of both sides here. So x is equal to the ln of 1. So if you want decimal approximations, what's the ln of 7? And what's the ln of 1? What? 0? Hey, are you sure it's 0? Why is it 0? Because anything to the 0 power is 1. So the only way that we get e to the x being 1 is if x was 0, right? Hopefully, when you saw this, you knew x was 0. Right? Don't have to take the ln both sides? Y'all knew that. All right. That's all there is on that first section. That's plenty.